Hello, 6th graders. Welcome to 6th grade math algebraic expressions lesson. Pause while you write the lesson title in your math notebook. Pause again while you write today's lesson objective in your math notebook. Today's objective is I can evaluate an algebraic expression containing a variable by completing practice problems with 100% accuracy in multiple attempts. Today's standard is to write, read, and evaluate expressions in which letters stand for numbers. We're going to start today's lesson by reviewing our vocabulary. If you have not yet written this vocabulary in your words worth knowing section of your notebook, you need to do that. An algebraic expression is an expression that may contain numbers, operations, and one or more symbols. Parts of an algebraic expression are called terms. A symbol that represents one or more numbers is called a variable. The numerical factor of a term that contains a variable is a coefficient. A term without a variable is called a constant. Let's take a look at example 1, identifying parts of an algebraic expression. Let's start by looking at the study tip off to the side. It says a variable by itself has a coefficient of 1. So the term y in example 1b has a coefficient of 1. So let me show you where they're talking about and what they're talking about. Here's the y. And if you ever see a variable or a letter by itself in an expression, its coefficient, the number sitting in front of it, is 1. So it's invisible. We don't write that 1 there all the time, but it's there. And it's important that you know that, and you'll see how that comes up later. So let's take a look at example 1a. 5x plus 13. The terms in this expression are 5x and 13. So you can think of the terms in an algebraic expression as everything in the expression except for the operation symbols. So 5x is a term and 13 is a term. A coefficient is the number that sits in front of a variable, is the simple way to put it. You have the official definition written down in your words worth knowing. So 5 would be the coefficient. And a constant is a number that doesn't have a variable next to it. So 13 would be the constant. Looking at letter B, we have 2z squared plus y plus 3. So the terms here are 2z squared, 1y, and 3. So those are all the terms. So they're the parts of the expression except for the operation symbols. So we just don't include the plus signs. And our coefficients, so the numbers that are sitting in front of the letters, are 2 and 1. And then the constant, so the number that doesn't have a variable after it or a letter after it, would be 3. Example 2, writing algebraic expressions using exponents. So it says to write each expression using exponents. So this is just how we did exponents back when we were using numbers, except that we're using letters. So if you get confused, think about how you would do this if D were the number 2 or something like that. So it works exactly the same way. So if we look at example 2a, we have D times D times D times D. And it says because D is used as a factor 4 times, except its exponent is 4. So D times D times D times D equals D to the 4th power. And then for example 2b, we have 1.5 times h times h times h. So we can kind of forget about the 1.5 for a minute because we have to think about how we're going to write those h's. So it says because h is used as a factor 3 times, its exponent is 3. So we have h to the third power, and then we just set the 1.5 in front of it. So 1.5 times h times h times h equals 1.5 h to the third power. Now there's a little clue above example 3. It says to evaluate an algebraic expression, substitute a number for each variable, then use the order of operations. So remember that's PEMDAS. There we go. To find the value of the numerical expression. So we're going to take a look at 3a. It says evaluate k plus 10 when k equals 25. So what that means is now, a second ago, we didn't know what k equaled. It was just a letter. So we couldn't add k and 10. Now that k is a number, it's 25, we can substitute that in and we can add it. So we're going to do that. So our first step is we're going to substitute 25 for k. So we're going to rewrite our expression, and instead of using k, we're going to use 25. So 25 plus 10. And then we're going to add 25 and 10, and that gives us 35. Letter B, we're going to evaluate 4 times n when n equals 12. So we're going to substitute 12 for n. So 4 times 12, we rewrite it. So 4 times, it used to look like 4 times n, now it looks like 4 times 12. And 4 times 12, we multiply it, and that equals 48. Let's move on to example 4. We're evaluating an expression with 2 variables. So you really do have to pay attention here and substitute in the correct numbers for the correct variables. So we have a divided by b, and a is going to equal 16, and b is going to equal 2/3. So we have 16 divided by 2/3. That's what happens when we substitute our 16 for a and 2/3 for b. So 16 times 2/3, we multiply by the reciprocal of 2/3, which is 3/2. There we go. And when we do that, we get 24. Example number 5. We are evaluating expressions with 2 operations. So we have 3x minus 14 and x equals 5. So we're going to substitute 5 for x. So we rewrite our expression. So now instead of 3 times x, we have 3 times 5 minus 14. So you need to remember that when a number is sitting next to a letter, it means multiply. So it's 3 times 5 minus 14, and 3 times 5 equals 15, and 15 minus 14 equals 1. So we used the order of operations. We multiplied 3 times 5, and then we subtracted. We're going to do this again. We're going to evaluate z squared plus 8.5 when z equals 2. So we write our problem first, and then we substitute 2 for z, and we rewrite it. So we have 2 squared plus 8.5. We use our order of operations. We evaluate 2 squared first. So 2 squared equals 4, and 4 plus 8.5. So we're adding 4 and 8.5 equals 12.5. All right, we are on example 6, our real-life application. You are saving money to buy a skateboard. You begin with $45. And you save $3 each week. So the expression 45 plus 3 W gives the amount of money you save after W weeks. So W stands for the number of weeks that you've saved money. How much money will you have after 4 weeks, 10 weeks, and 20 weeks? So that's question A. Question B is, after 20 weeks, can you buy the skateboard? And explain how you know this. So let's look at our little chart here. So the skateboard costs $125. That's important to know. And our chart has the number of weeks that they've asked us about, which is 4 weeks, 10 weeks, and 20 weeks. And the middle column has our formula, which is, or our expression, which is 45 plus 3W. So remember that W stands for the number of weeks that we've been saving money. So we have 45 as a constant there because we started with $45 and that doesn't change. And then we save $3 a week. So the only thing that changes is the amount of time that we've been saving our money. So after 4 weeks, we saved the original $45 plus 3 times 4. So 45 plus 12 equals $57. After 10 weeks, we have saved 45, the original $45, plus 3 times 10 weeks, which is $30, and that equals $75. After 20 weeks, we've saved the original $45 plus 3 times 20 weeks, which is $60, so that's $105. So if we look at our question, again, for question B, it asks us, after 20 weeks, can we buy the skateboard? And so our answer is, after 20 weeks, we have $105, so we cannot buy the $125 skateboard. We do not have enough money. Here's what you need to do next to finish this lesson. You need to be sure your notes are complete in your ISN, complete your Google Form questions, review your lesson if you need to, and complete your Big Ideas math assignment in your Math Spiral notebook. Be sure you submit that when it is 100% correct, not before, and track your progress on your playlist.